Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number, I think it's 10. Yep. 10 part C. We're done. Yeah. 10 part C from the October-November 2021 Cambridge 9709 A-Level or International A-Level Pure Mathematics Paper 1 Variant 1. This is question 10 part C. And we're told that the normal to this curve, which we were given in parts in the first parts of the question, the normal to this curve at the point 1, 1, okay, which is going to be exactly here, 1, 1, that's the point on this curve, crosses the y-axis at the point A. So the normal to the curve. Now, what is the normal to the curve? Well, the normal is a straight line which is perpendicular to the tangent to the curve at that particular point. So the tangent to the curve at 1, 1 would look something like this. It would be a line which just touches the curve at that point without cutting through it. So it shares the same gradient of that point. And the normal would be a line which is perpendicular to that. So it will be going through the same point, but going through at right angles. Okay, so this would be the tangent here. This would be the tangent here. And this would be the normal. So we need to find the equation of the normal to the curve. Now, to find the equation, the normal is a straight line. To find the equation of a straight line, in fact, we don't actually need to find the equation of the normal. We need to start finding the equation of the normal, and then we'll see how we can get the y-coordinate straight away without actually having to go all the way through to find the equation of the normal. First things first, I know this is the point 1, 1. So to find the equation of a straight line, we need two things. One of them is a point on the line, which we have. The second thing we need is the gradient of the line. Now, the gradient of the normal and the tangent are perpendicular. Okay, the tangent line is perpendicular to the normal line. Okay, so if I can find the gradient of the tangent, then the gradient of the normal will be the negative reciprocal of that, because the gradients which are perpendicular will have gradients which are negative reciprocals. So I need to find the gradient first of the tangent. So if I find dy dx, so first of all, let's say y is equal to 3x minus 2 to the power of negative 3 over 2. So the first step is to find the gradient function for the curve, and that will tell me I'll be able to find the gradient of the curve at that point, which will be the same as the gradient of the tangent at that point. So dy dx here, now you've got to be very careful when you use a chain rule here to differentiate. You have a function inside a function. So we multiply by the power, so minus 3 over 2 times, you have 3x minus 2. You take 1 from the power, that gives you minus 5 over 2, because you take 1 away from, you have minus 3 over 2 minus 1, so that's minus 3 over 2 minus 2 over 2, which is minus 5 over 2. But don't forget then we have to multiply by the differential of what's inside this bracket, which is 3. That's something that a lot of students forget to do, and then they mess up the question. So therefore we can say dy dx, the gradient function, is going to be negative 9 over 2, and times, what I can do is I'll write this as 1 over the square root of 3x minus 2 to the power of 5. Okay, to the power of 5, because we know the rule a to the power of m over n is equal to the nth root of a to the power of m. The denominator is the root, is the root, the denominator is the root, and the numerator is the power. So the denominator is the root, so square root, and the numerator is the power, and the negative is from the fact that you have a to the power of minus n is equal to 1 over a to the power of n, so it becomes in the denominator. So we're left with dy dx. The gradient function is minus 9 over 2 times the square root of 3x minus 2 to the power of 5. Okay, so now at the point 1, 1, x equals 1. So that means the gradient of the tangent would be what you get when you put 1 in here. So you have minus 9 over 2 times. So 3 times 1 is 3, minus 2 is 1. So you end up with the square root of 1 to the power of 5, which is going to be 1 anyway. So you end up with minus 9 over 2. Okay, therefore the gradient of the normal is a negative reciprocal, which is going to be positive 2 over 9. That's the gradient of the normal. It's the negative reciprocal of the gradient of the tangent. because these are perpendicular to each other. So now we have a 0.11. We have the gradient of the normal 2/9. So therefore we can say y minus y1 equals m times x minus x1. So we have y minus 1 equals m, which is 2/9 times x minus 1. Now we know on the x-axis, on the y-axis, we're trying to find where it hits the y-axis. So we can say on the y-axis, okay, on the y-axis, all right, x is equal to 0. We know that's true. On the y-axis, x is 0. On the x-axis, y is 0. So now all I have to do is replace the x with 0. So I have y minus 1 equals 2/9 times minus 1. Okay, so you have y minus 1 equals minus 2/9. Therefore, y is equal to minus 2/9 plus 1. So that's going to be minus 2/9 plus 9/9, which is y is equal to 7/9. That's the y coordinate at the point A. Okay, so the y coordinate of A is 7/9. They only want the y coordinate, okay, of the point A. A is the place where it crosses the y-axis. Okay, so there's, well, of course the x coordinate, the x coordinate is going to be 0 there anyway. So there's the answer to that question. So we don't actually have to find the whole equation of the curve. It's not a big deal if we do. It's just going to be y equals 2/9 plus 1, okay, plus 7/9. So 7/9, it will be 2/9 x plus 7/9. So we can see 7/9 is the y-intercept. So there's the answer to question 10, part C. I hope that was clear. Other questions from this particular paper, including 10B, 10 part B and C, can be found in the playlist that will be linked over here. The link here will be to questions involving differentiation for P1 in Cambridge. I'll also put a link here for differentiation for P1 and, well, P2, I guess. Maybe P1 and P2 from EdXL. Thank you for watching. See you soon.